Hello again, and this video is prepared for question 6.86. Here we have a water jet, and it strikes a card, as you can see here. So after striking the card, the water is deflected vertically with respect to the card. So we have a water jet, and it is striking this card, and it is deflected vertically. And the card is initially at rest, and it is accelerated by the water jet. The mass in the water jet is much less than that of the card, and there is no resistance on the card. The mass flow rate from the jet is 45 kg per second, and the mass of the card is 100 kg. So we need to find the time required for the card to achieve a speed 1/2 of the jet speed. So this means we will have Vc, which is velocity of card, equal to half of V jet. So in this question, on the contrary of other questions, we need to use the simplified general equation of momentum equation, because this time we have acceleration, so that we will also consider this equation, this term as well. So let me write what we have. So we have m velocity, and we are going to find the change of m times v over time. And here, this is the velocity in control volume. And so since the card is accelerated, we need to use the velocity of the card. And for that, let me first draw the control volume. So we can take entire card as the control volume. And also in the question, it is stated that the water is deflected vertically with respect to the card. So here we can take the reference point within the card. So this helps us to simplify the question because the deflection is vertical with respect to the card. So that we can directly take this vertical deflection. So that, for example, we will have something like this. And if we go back to the momentum equation, we can write this in this form. We have d over t again, and we have m, and we have vc, which is the velocity of card. Then here we will have the out minus in. So we have mass flow rate. The out is the card velocity, and the in is velocity of jet. So we can say Vc minus Vj. And in this question, since we have velocities on the same direction, since we have two velocities, we actually need to find relative velocity. So that it will be the velocity that strikes the card. So we have velocity of jet minus velocity of card. And since this is the relative velocity in this system, we will use this velocity as the velocity within the mass flow rate. So mass flow rate is rho area times velocity. So we will have rho a and we will also add the other velocity term. And this is actually the total horizontal force. And since we actually calculating dealing with the acceleration and velocity, and we have this horizontal force, we can actually ignore this vertical momentum. So we will do all our calculations for the horizontal direction. So here we can actually do some more modifications. So, and here, since the mass is constant, we can actually send it to the outside. So here we have rho A Vj to Vc to Vj minus Vc square minus Vj square. And since we are trying to provide equilibrium, this is 0. So if we send this equation to the left, we will get this form. And here, since we actually need to find something similar to this term. So for example, we can modify it like Vc over Vz is equal to 0.5. So to make the calculations simple, we will try to obtain this term in our equations. So you will understand it better now. So we can actually modify this equation as So this part may seem a little bit confusing, but when you do internal calculations, you will get this one. And with more simplification, we will actually have a mass flow rate of jet, because the mass flow rate of jet is rho a v jet. And we did that because in the question, we actually have the mass flow rate from the jet, which is 45. So let me write that. We have mass flow rate of a jet times the velocity of jet. And this is equal to dt of velocity of kite. So with more modification, we are going to get d over dt Vc over Vz. So main reason for that, because we need to find the time. So we moved this term and so we created this term to calculate the required time, so that we write it in this time term. So let me continue. We have m dot. We have also m, which is mass. So here basically we did, so we moved this one here. We moved mass to the left hand side. Sorry. We moved the velocity of jet to right hand side into this derivative, so that we obtained this one, which is the change of Vc over Vjet over time. And we kept this here. So the only change is with this one and with this term. And let me continue. So again, we have Vc over Vjet over 1 minus Vc over Vjet square. This is equal to mass flow rate, and we are moving this term to the right. So that actually eventually we are going to find the delta t, which is a change in time. So the main reason for these calculations, these modifications to calculate the required time. So here we can actually call this u, just to make calculations simpler. And this is also u. So here we have du over 1 minus u squared, which is equal to m, mass flow rate, m dot over m. So we will get integral. So here at this step, we need to use actually t is equal to 0. And then we need to find t is equal to delta t, which will give Vc over Vz is equal to 0.5. So let me continue with that. So this is 0 and this is 0.5. And for the right hand side, we have t and we have delta t. So here we actually have 1 minus tu minus square du. And this is actually going to be m dot over m delta t. And this delta t is the required time to obtain this relationship, which is the cutoff velocity will be half of the jet of velocity. So from here, we are going to get a derivative of inside u. It's also minus 1. So this is going to give 1 over 1 minus u. And we have two terms, which is t is equal to 0 and the other one is 0.5. And so this is not, sorry, let me clarify this. So this is the Vc over Vz is equal to 0 because we already made this relationship. U is equal to Vc over Vz. So in the question, it is saying that the kite is initially at rest, which means at t is equal to 0, we will have b kite is equal to 0. So this 0 is coming from being initially at rest. And then it was saying that the kite velocity of kite will be equal to half of velocity of jet. And this also means Vc over Vz is equal to 0.5. So from here, we will get 1 minus 1 over 1 minus 0.5 minus 1 minus 1. And this gives actually, so this is 1 over 0.5 minus 1. So from here, we will get 1. So let me continue from here. And let me use this color. So 1 will be equal to mass flow rate over m, which is mass delta t. And delta t is equal to mass over mass flow rate. And the mass of the kite was 100 kilogram. And here the mass flow rate is actually jet, because jet and mass flow rate of jet, because in this equation we found that relationship, so that it is actually the mass flow rate of the jet. So it was given as 45 kilogram per second. So this makes delta t as 2.22 seconds.